In this episode, we're going to look at how to examine the address resolution protocol table. I'll show you how to do it and have a discussion of the concepts on the way. We're going to be viewing protocol data units. The devices are already configured. We're going to gather PDU information and then answer a series of questions about the data we collect. We'll look at examining the ARP request, examining the switch MAC address table, and then finally examine the ARP process in remote communications. Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. This episode is part of my series on practical configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Examine the ARP table. Here I have Packet Tracer Lab 9.2.9 open. On the left side is our main Packet Tracer window. Lab is loaded up. On the right side, I do have our Packet Tracer activity windows. The bottom right is the one that comes with the actual Packet Tracer. The top one on the right is a Word document of that Packet Tracer activity window. The reason I use the Word document is it allows me to enter my answers in and save those. Here we have the addressing table. If we look at the addressing table, it gives us our devices. It says what interface we're using, what the MAC addresses are, and then what interfaces they're connected to on the switch. Here we have our objectives. We're going to examine an ARP request. We're going to examine the switch MAC address table, and then we're going to examine the ARP process and remote communications going across multiple networks. Part 1. Examine an ARP request. First thing we're going to do is we're going to generate an ARP request by pinging. We're going to ping from 172.16.31.2. I'm going to go ahead and click on that. I'm going to go ahead and open up my command prompt, which is on the desktop tab. Go ahead and click on command prompt. And then I'm going to type in ARP space -D. What that does is it clears the ARP table. It makes sure there's nothing in there at this point in time. Step C, enter simulation mode. And once again, down here is where we change it in our main Packet Tracer window. We go from real time into simulation. Go ahead and click on simulation mode. And they want us to ping 172.31.3. And that is from our command prompt on 172.16.31.2. I'm going to go ahead and type in ping space 172.16.31.3. When I do that, once again, we're in simulation mode. We create two PDUs here. I got one purple, one green. Your colors are going to be a little bit different, but you're going to have two different colored ones. It's going to create two of them. The purple here is the ICMP. Ping is part of the ICMP family of protocols, but Ping uses an IP address. It doesn't know the MAC address associated with it in order to find that out because we're delivering it on the same network. We need to know what the delivery MAC address is, the destination MAC address, but we don't know it. That's where we start the second PDU. That's where the address resolution protocol, the ARP request, comes in. On to step D, click the capture forward once. Down here, this is the button they're talking about. It's the arrow pointing to the right to the solid line. Click that once. The ARP PDU, once again, that was my green one, it now moved to the switch. While the ICMP disappeared, why it disappeared is it's being put on hold. It's put on hold because we are trying to get that destination MAC address. We're waiting for the address resolution protocol, that ARP request, to complete its process and give us the MAC address. Open up the PDU, clicking on that green envelope. Once again, mine's green, your color will be different. And record the destination MAC address. What is the MAC address? What we're looking for is where is this going? For me, I click on the outbound PDU. It helps me. I can look at the layer 2 Ethernet frame header here. Destination MAC address is right there. Destination MAC address is all Fs. It is FFFF dot FFFF.FFFF. This is a special MAC address. This is a broadcast MAC address. When it sees this as a destination MAC address, we're going to broadcast it to all devices on our local network. Is this address listed in the table above? We can go up there, we can scroll and look at the table. We don't see any MAC addresses here that are all Fs. It's a special MAC address. Do we see that? No, we do not at that point in time. Click the capture forward button to move the PDU to the next device. I'm going to go ahead and close the window we have right there. I'm going to click the next button right here, and it's going to move it. How many copies of the PDU did switch 1 make? Well, one went up to router 1, one went to 172.16.31.4, and the third one went to 172.16.31.3. So it made 3 copies of it. What is the IP address of the device that accepted the PDU? We can look at the graphics here and we can see the PDU copy that went to router 1, we can see that there's a red flashing X on it. That red flashing X means it looked at it, it looked for the matching IP address, its own address, compared it to the destination IP address, and the ARP request doesn't match, so the router 1 discards it. Same thing happened down here with the .31.4 PC. Destination MAC address didn't match its own, so we discard it. But the one where we don't have a red flashing X, it actually accepted it. The IP address here is 172.16.31.3. There we go. Question or step F. Open the PDU and examine layer 2. I'm going to go ahead, click on the PDU here that's on .31.3. We open up our informational window and we will examine layer 2. We now see when it came into the .31.3 PC, we have it came from this MAC address that ends in 1DA7, and it was destined for all devices. That was our broadcast MAC address. Now, as it goes out, we see our layer 2 Ethernet header. This is the source MAC address. It was destined for FFF. We process it. We create the the ARP reply. And so what should happen is the original destination MAC address should now be the source, but because it was a broadcast, we now put in the MAC address of the .31.3 PC because we now know it. It's going to the .1DA7 MAC address, which was the source of the layer 2 frame ARP request. Because we knew it, we got that from the ARP request, we could then put that in there as the destination here. What happened to the source and destination MAC addresses? The source MAC address becomes the destination MAC address, and the new source MAC address is the MAC address of the PC sending the ARP reply. Click capture and forward until the PDU returns to .31.2. What I'm going to do is I'm going to go ahead, I'm going to click it again. PDU moves from .31.3 PC up to switch 1. Click it again, it's now going to move from switch 1 down to .31.2. How many copies of the PDU did the switch make during the ARP reply? How many copies of that PDU did it make? It only made 1. Now, it did not have to broadcast it out because Remember, when it created that reply there, we didn't have to send it out as a broadcast. We knew where that ARP request came from. We could take that source MAC address and put that in our destination, and we don't have to broadcast it to everybody. It only did that once. And our answer here is 1. Step 2, examine the ARP table. Note that the ICMP packet reappears. My second envelope, my purple envelope, now reappeared. If we look up here in the simulation panel, we can see it did appear right away. Do the MAC addresses of the source and destination align with their IP addresses? I'm going to go ahead, open up the PDU, and look at the information. The information here, yes, it aligns with it. It's exactly what we looked at, what we've done. The IP address does match up here. And so the answer we have is yes. Switch back to real-time mode. I'm going to go ahead and close this PDU information window. Switch to real-time by clicking on it. It completes the ping. Step C, click on 172.16.31.2. Open up our command prompt. It's still open. Enter the ARP-A command. ARP space -A. What that's going to do is list out all the entries in the ARP table on the PC. To what IP address does the MAC address entry correspond to? Looking here, there's only one MAC address, and it corresponds to 172.16.31.3. 172.16.31.3. In general, when does an end device issue an ARP request? An end device issues an ARP request when it doesn't know the destination MAC address. It knows the IP address, but it needs to send it to the MAC address, because once again, the information goes from one network interface to another network interface. We need to know what that MAC address is so we can send it there. If we only know the IP address, that's when we issue the ARP request. When it does not know the receiver. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Part 2. Examine the switch MAC address table. Open a command prompt. From 172.16.31.2, ping 172.16.31.4, ping 172.16.31.4. We'll send that ping. It works. Close that window. Click on 10.10.10.2. Open up our command prompt. It's on the desktop tab. Click on command prompt and ping 10.10.10.3. Go ahead, ping successfully. How many replies were sent and received? If we look at the ping here, the information, we have a reply here, we have a second reply, third reply, fourth reply. But if we look underneath here, underneath our ping statistics, we can see that we sent 4 packets and we received 4 packets. Sent 4 and received 4. Go ahead and close our command prompt. Next step is to examine the MAC address on the switches. Click switch 1 right there. Then the CLI tab. Enter the command show MAC address table and see what it says. I'm going to hit enter a couple times, give us a clean working area. We have to be in privilege exec mode. In order to get the privilege exec mode, we type enable and hit enter. Notice our prompt change from the greater than sign to the pound sign, the hashtag. Question, or now we have to enter in our command. Show space MAC dash address dash table. It gives us a MAC address table. Do the entries correspond to those in the table above? Well, I'm going to go ahead. I am going to scroll up to the top here, look at our address table. We have MAC addresses of 8D75. 8D75 is right here. That connects into switch interface F03. 8D75 says it's on F03. We have 1DA7, says it's on F01. 1DA7 is right here. That goes to F01. That matches up. 2849, that's on F02. 2849, F02. And we have 8901 on gig 01. 8901 on gig 01. Yep, those all match up. Okay, go ahead. Now we click on switch 0. Open up our CLI. Enter in that same command. Hit enter several times. Gives us a working area. Type enable to get into privileged exec mode. Now our command show space MAC dash address dash table gives us information. Does that match to the table above? Once again, we'll jump up to that table. We have MAC address ending in 2501, shows gig 01. 2501's right there, top one goes to gig 01. That one matches. DAB6 goes to FA02. DAB6 goes to F02. And our last one, 572B, goes to F02. Here we have 572B goes to F02. Yep, those all match up. Next question, why are 2 MAC addresses associated with one port? Why are 2 MAC addresses associated with one port? If we look here, switch interface F02 is listed twice. That was on switch 01 here. But they have 2 different MAC addresses. And once again, F02 is this line connecting down here that goes to the access point. The access point then connects into both of these devices. Each of those 2 laptops have different MAC addresses. And that's why we have 2 MAC addresses that map to the one port on switch 0. This other F02, that's on switch 1, so it's a different switch. But these 2 are on the same switch. And they have 2 different MAC addresses associated with them because they go into an access point. Those access points can connect multiple devices. Each device needs its own MAC address. Because both devices connect to one port through the access point. Part 3, examine the ARP process in remote communications. We're going to generate some traffic here. Open up a command prompt on .31.2. Open up our command prompt and ping 10.10.10.1. Ping 10.10.10.1. Looking at our diagram, we are on this laptop right here. We're going through a switch, through a router, through another router, and that 10.10.10.1 is actually the interface that connects to that far LAN. So that IP address is right here on this connection. And we went through there. Now let's type in ARP-A. ARP-A. And if we look in here, there's one new address. This one new address is 172.16.31.1. Well, where is that one? 172.16.31.1. Well, I can go ahead and minimize this. Looking for that down here, 172.16.31, and we're looking for .1. Here's .2, .3, .4. It must be on this network, so it's not after the router, it's here. Switches don't have network interfaces. They don't have NICs, so we can't put IP addresses there. Must be on this router. If we mouse over this router, a pop-up window will appear, and sure enough, if we look at gig ethernet 0/0, there's that IP address. It's 172.16.31.1. That is our default gateway for this right network to get off of our network, connect to a different device that routes us to other networks. That is our default gateway. That is on this network, but it's connected to a device that can get us to other networks. Step D, they want us to enter in ARP space -D to delete all the entries in the ARP table, and then switch to simulation mode. So we've deleted all entries in our ARP table. Now they want us to ping that far end of router 0 again, so that was ping.10.10.10.1. Go ahead to process, and if we look here, notice we have 2 PDUs that started. If we go into the simulation panel, we can see that my lighter green here is ICMP, that's the ping, but then we have the darker green here, that's an ARP request. Now we have to go through the ARP process again because we deleted all ARP entries. And so how many PDUs occurred? We had 2 PDUs that occurred. Go ahead and close the command prompt. Click the forward capture button. The PDU is now at switch 1. This right here is the forward button. We'll see that my dark green PDU, the ARP one, now went to switch 1. What is the target destination IP address of the ARP request? Go ahead and click on the PDU. We can see in here, I'm on the OSI model tab, we can look at layer 2 where we do an ARP packet. Our destination IP address is 172.16.31.1. 172.16.31.1. If we remember correctly, that was the IP address of our default gateway. The destination IP address is not the 10.10.10.1. 10.10.10.1 is the command we typed in. We typed in ping 10.10.10.1, but our destination of our ARP request is 172.16.31. Why is that? Well, it has to do with we are crossing networks here at this point in time. The gateway, I'm going to go ahead and close this window. We started here at .31.2 PC. We went up to this router. This router is connected to another network. And so what we have to do is get our frame from this PC up to this router. This is this MAC address. This is our exit off of here. This is our default gateway. So we have to go to this IP address with this MAC address. And then once we're there, we can then look at our IP address. The routing protocol knows if we send it out our serial connection, that it's going to get closer to its destination. Why is it not 10.10.10? The default gateway address of the router interface is stored in the IP version 4 configuration of the host. This IP version 4 configuration information, you entered it either manually or through a DHC process. You included the IP address, you included the subnet mask, you included the default gateway. It knows the default gateway is the exit off of its network, so it knows that destination IP address. If the receiving host is not on the same network,
The source uses the ARP process to determine a MAC address for the router interface serving as the default gateway. So it uses that information you entered as the administrator, gets that IP address of the default gateway, then it gets the MAC address for that, and then we can send it off to that. Step 2, examining the ARP table on R1. Switch to real-time mode. Down here, we're going to go from simulation to real-time. Click router 1. What clicking real-time did, just finished out the ping really quick. So click on router 1 and the CLI tab. You can enter a couple times, give us a working area, get into privilege exec mode by typing enable, and then type in the command show space mac dash address dash table, and it's blank. How many MAC addresses are in this table and why? There are 0 MAC addresses in here, and yes, that is the correct answer. Now, why is there 0 in there? To a router, this command means something completely different. Think about that. Routers don't necessarily keep track of MAC addresses. Routers keep track of IP addresses, layer 3 addresses. MAC addresses are layer 2. Router is a layer 3 device that deals with IP addresses. This command means something completely different than the switch command show space mac dash address dash table. C, enter the show ARP command. Show space ARP. I'm going to make this window a little bit wider so the formatting looks a little bit better. Is there an entry for 172.16.31.2? Oh, right here. There is an entry for it. What happens to the first ping in a situation where the router responds to an ARP request? Now, when you send out a ping, Windows is going to try to ping 4 times. Cisco iOS is going to ping until you interrupt it. So there's going to be lots of pings happening. The first one a lot of times fails because it has to go through the ARP process. It needs to do the ARP process a minimum of once a lot of times, and sometimes it may need to do it 20, 30 times. By the time it's done completing that ARP process, the first ping has timed out. First ping times out. It takes too long to get an answer. And that takes us to the end of Packet Tracer Lab 9.2.9, Examine the ARP Table. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.